implement the actual loops recursion, or you didn't have time? No.
I couldn't figure it out.
Oh yeah. Any specific areas where you stuck, or is just the overall logic?
Like the whole thing.
Okay, well, we can look in that today, but and have you started any coding, or just kind of trying to wrap your head around the entire thing?
Yeah, I mean, I did this two methods, the partitions and quick sort, but yeah, they're pretty much empty. Just copied whatever you were saying we should do, and I just couldn't understand how to do it.
Gotcha. Okay, well, we can look at some examples today and see if we can get that finished and get some coding around it. But yeah, the coding part is definitely going to be a little bit harder. But I wanted to so what do we want to start? So I wanted to answer any questions around that and hopefully get us into coding, but I also wanted to cover one other area in Java of the sort is bubble sort. So do you want to cover the bubble sort, or spend a little bit more time on quick sort? What do you guys want to do first? The bubble sort is much easier, so maybe you get a win.
Let's do bubble sort.
Yeah, I agree.
Yeah, okay. I know. Sometimes, it's just better to take some time off from something hard, like quick sort. So, and the reason why it's, hard is because it saves a lot of time. So, things that are, that do a lot for you usually are a little harder to get, as with a lot of other things in life. So, don't feel bad, that's you couldn't wrap your head around. I'm still struggling with kind of the quick sort itself. So it's it's a tough algorithm to grasp, but it's definitely the fastest. So that's why it's a little, it's complicated, but it's definitely worth the effort, and it's really used in Java. So, but let me cover. So bubble sort. So let's cover that. I think that's gonna be quicker, and you guys can do an exercise in class to do this. So bubble sort is a very simple strategy, but it's also a pretty time-consuming strategy. So it's really good for small data sets. So when you don't have a lot of, your arrays or data sets are small, you need to sort it, you usually use bubble sort, or there are a couple other sorting techniques that you could use. They're all, bubble sorts are all O(n) square, time complexity. You're going to see multiple for loops, so in nested for loop in implementation, that's kind of the thing here, and that's why it's pretty slow. So if you need to sort through millions and millions of records and get it sorted, then you're going to use quick sort. But when we talk about small sets, maybe some you already have a subset of things and you need to sort it quick in your code. So maybe you have something like a UI sorting technique or something like that, where you basically sorting maybe contents of the page or something like that. Maybe user clicked like a sort on the listings, right? Like on a website like Zillow, where you have like 100 listings of houses, and then you sort through by the price from high to small, or small to high. That's small amount of data. So no need to do something crazy like this because you're now dealing with a lot of data. So small sets is where you're going to be. Small sets is example of that's suitable for bubble sort, which is a called comparison strategy versus kind of the divide and conquer strategy that this has, right? Divide and conquer strategy, remember, so basically we're constantly dividing our data set by taking a pivot, and then we're basically comparing things to the pivot, and then you basically breaking things into left side of the pivot, right side of the pivot, and it's kind of a division, right? And then once it's all divided and we have nowhere to go, we are sorted. Here, it's more of a comparison strategy. We're not going to be dividing anything. We're going to be comparing things to each other. So, as I mentioned, it's pretty slow in square complexity. The more elements you have, the steeper your time is going to be. But if it's not a lot of data, like I said, it's okay. So let's get into that. So you usually start with a first element. So this is the steps. So start with the first element and then compare that first element with the next element of the array. Start with the first, compare first and second. If the current element is greater than the next element of the array, then you swap. So, basically you bubble up, right? And if the current element is less than the next element, move to the next element. So you repeat step one until you get to the end, and then you start over again. So it's pretty dumb, but you basically, what you're going to see that in this example, you're going to be bubbling up each element to the top. So let's see how this works. Now we can look at the spreadsheet example as well. So let's start with this array, right? And so we start at 5. I like it. So we are comparing 5 with the next element. So 5 is greater than 1. So we are swapping 5 and 1 here, right? And then we're moving to, moving forward. So we got 5 and 1 here, right? We're swapping them, and it goes, we're gonna have 1 and 5, right? So, and then, we compare, so we move to the second element, we compare 5 to 6, and 5 is, less than 6, so we are okay here. And we move to the third one, and we find 6, right? Then moving on, comparing again, same way, we find that 6 is greater than 2, so we need to swap it, right? So, 2 and 6 are swapped. Let me get Helen here. So 2 and 6 are swapped. Continuing with that, right? Then we'll see the same thing here. For encounter 4, the next element, we swap 4 and 6, right? And then once we get 6 here, we see the next element is 3. So we swap 6 and 3, right? That's the first pass. So as you can see, we kind of start with a 5, and we keep bubbling that up until we hit a larger number, really, right? And then we move to the larger number, and we bubble up the larger number until we hit the end, right? Or there is another larger number. As you can see, 5 ended up here, and 6 ended up all the way at the end. So we bubbled up basically at the first pass. At each pass, we bubble up the largest number we see in that pass all the way to the top. So after each pass, the largest number, the second largest number, the third largest number, fourth, so on, I'm going to end bubble up to the top. All right, so this is just the first pass. As you can see, we're still not sorted. We bubbled up the largest number to the top, but as you can see, we're still not in sorted order. So we go again, right? I mean, this picture doesn't show it, but hopefully it's clear that we start again. 1 compared to 5. Okay, they're okay. Moving on to 5. 5 compared to 2. We swap 2 and 5. So 5 gets here. Then we compare 5 and 4. Okay, still 5 is greater than 4, so swap. 5 gets here, and then compare 5 to 3, swap. 5 gets here. Compare 5 to 6. 5 is less than 6. We're done with this iteration, with that loop. So then, you know, the second iteration of this, 5 gets here, but we're still not sorted in there. So we keep doing until we are, you know, we're done with this. So how do we know we're done, right? We could be done. What's our strategy for being done? Because we're going to be looping, right, and comparing, and the computer doesn't know that we're done unless we tell them, right? Just because we're not moving things, we shouldn't be just continue looping and comparing. So that is done if we have one path without any swaps, right? One pass without any swaps means that there was nothing else to be moved or swapped. So as you're going to be doing this, you need to make sure that you have a counter for the number of swaps for each pass. So that's the key there. So every time you do a loop, you need to count how many swaps you have, in that loop, in that iteration, right? So here we did 1, then we did 2. So once you have 0, then you're done, right? You don't have to go through that other loop again. Okay, so before we get to a spreadsheet example that will do the full thing, is this clear on kind of the core concept? Bubbling up each element to the top.
Yes.
Cool. Much simpler than this, right? But at the same time, it's pretty basic. So all right, so if we start here, let's say, we have this array, small array. So let's kind of go through that as an example. Oh, we go start with the first one, right? And then we go compare 5 and 1. So this is our first iteration. We swap 5 and 1. Then compare 5 and 4. We swap 5 and 4. So as you can see, 5 keeps bubbling up, right? We compare 5 and 2, the next element. So we swap 5 and 2, and then we compare 5 and 8, and we don't swap because 5 is less than 8. So we've bubbled up 5 all the way that we could, the way here. How many swaps we did here? I think we did 2, right? Doesn't really matter how many, as long as we did more than 1. So I think we did 2 swaps, if I'm not swaps. So we did 2. So based on the rule, we're saying, okay, are we done? No, we did 2. So we're probably not done. So we go back, as you can see, it's not really done yet. 1, 4, 2, 5, 8. We only got up to here. So we go again, same rule. 1 compared to 4. Okay, it's good. So no swaps here. Then move to the 2, compare 2 to 2. I'm sorry, compare 4 to 2. And 4 is greater than 2, so we need to swap them. 4 goes here, 2 goes here. Okay, and then you are at the second index, comparing 4 to 5. for less than 5, so we are good. So we're good. 5, and then we compare, move on to 5, compare 5 to 8, and we're good here. So we're not moving anything, those elements. We did one swap, right? We did one swap, as you can, we swap. But if you look at this thing, you see that it's already done, right? We see that it's done, but the computer doesn't know that, and doesn't know, because we just did one swap, so we are not at 0 swaps. So that's a wasteful kind of algorithm, because we're going to go again until we get 0 swaps. So we're here, compare 1 to 2, then compare, move on, because there was no change. 2 to 4, all good, move on. 4 to 5, and 5 to 8, and then we're basically saying now we did 0 swaps. So that's all, right? Basically, the last swap is kind of usually a verification for the computer that we have done no swaps. So that's about it. We are done here, and then we break out of our a while loop, right? So you probably can do something, do while swaps equals 0, not equals to 0, do this. So, once you're here, you're done. So, so that's really it. Any questions? That useful?
So the time complexity of this algorithm is O(n) square.
Yep.
Mm-hmm.
Yeah, because you basically have, you're potentially going through, remember, we went through these elements multiple times through the same set of elements, because we're comparing each one to another multiple times. We go 1 time, 2 times, 3 times, and we go through each one comparing. So it's basically nested loops, and that means that the more elements we have, our time that we spend on this is gonna really go steep up, because we're not only going in a linear fashion, but we are going much faster. We're spending way more time, because we're visiting each element multiple times in the array. So, question for the group, if this is clear, how can we potentially make it a little bit more smart, little smarter than I just showed? Remember, we are bubbling up each element, largest element at the end. But then the way I was showing that, right? So we know after each round, the largest element for that round is going to come to the end. But remember, as I was going through, I was showing that we have to go for each loop and compare. You remember, at the last loop, I compared 1 to 2, 2 to 4, 4 to 5, and 5 to 8. How can we make it a little smarter? What do you guys think?
Maybe we do not iterate till the end of the array, each time just -1, length -1.
Yeah.
Minus I, right? Minus I. That's minus.
Yeah, exactly. So we know after each time that the last element is going to be at the right position. Next loop, another element is going to come bubble up right before it. So we do 2 loops. If we do 2 loops, we know that the last and the element, as well as element before it, like you say, is going to be in the right positions. So why even compare things to those elements? So why don't we keep some kind of we can do either the number of elements or something like that, and or managed by using I minus 1, I minus 2. So keeping track of the element, the last element, the element before last, and so on will help us save some time. It's not going to change our complexity. We're still going through elements again. So no matter what, we're still going through the first bunch. So that's still going to be considered O(n) square, but we could save a little bit time there. So if you could put that in your code so that you don't go onto the last element all the way to the last every time. So how would we, let's write some pseudocode on this and you guys tell me. So how do we actually do this, right? So what do you guys think? Give me some pseudocode. So what are we doing? Go for each element that already, right? And we know until until changes are made, right? So this is kind of the big thing, kind of the outer loop. So we have to go for each element. So that's our largest counter, right? So start with element 0 there to element so I, the element I plus plus, right? So what happens here?
If element at I is greater than element at I plus plus, we need to swapping.
Okay, so then we swap, right? So if 5 greater than 1, we swap them. If not, then we don't do anything. We basically, else we basically go to next, right? So by using the for loop, so your your counter advances. So here, what else do we do if we swap? What else do we need to do? We swap them. What do we need to remember? We need to note something.
Oh, there should be a variable for swaps, you said?
Yeah.
And which is just incremented each time we swap.
Either increment, or we could say, so here, let's introduce, so this is going to be a variable under the high, like the initial for loop, right? So we have this big counter. So you can do number of swaps, or you can do a Boolean, probably, right? I think you can do bool swap equals false, or oh, that's, I think maybe we can, if we do here, well, equals true. So we get into this loop. And then hey, so here, if we swap, then we gotta swap equals true. How do we set it to false? Where do we want to set it to false? Somewhere we have to set it to false, right? How about what if we do it here?
Yeah.
Right. So I'm figuring this out on the fly, as you can see. I forgot since last time we did the class, but yeah, I think that'll work. So basically we're saying, okay, we gotta, remember we wanted to say, we wanna do this while loop, some conditions swapped, we wanna keep doing until it's swapped. And then we're basically saying, okay, let's start as true. And we get into this loop, we've sent it to false. And then this is the inner loop. And we're saying we keep going in the inner loop, bubbling things up. Doing this, and then if we did something, then we're basically going to set it to true. And then, you know, if it's true, then after this loop is done, we go into this outer loop again. And then we're going to say, okay, it's true. We set it to false again, and do this again. So this is all. And if not, and at the end, we basically return, the array is going to be sorted in place, nothing needed. So you already know how to swap elements. So you're gonna write a little function to actually swap, right? We've done this before. Takes two elements, so it takes an array and uses the temporary variable to put one element in there and swap in place. So that's about it. So is this enough for you guys to finish and get a working code? Any questions?
Is it supposed to be a recursive function?
Can you make it?
No.
I don't know. Is there a recursion in there? I don't know. Think about it. Maybe. So if there is a, I mean, recursion usually works best when you have this divide and conquer things where you have like, you doing the same operation, you're just doing that on a smaller amount of data. That's the whole point, right? On that of divide and conquer, you basically say, okay, I have this huge array, but I'm not going to go through the whole thing. I just need to go through half of it, and then, but it's the same operation. Here, we're still kind of going through the entire set of elements, and we're comparing. If you find a way to do the recursion, please. But I don't see it right at the bat. That doesn't mean that it's not there. All right, so let me put this in Teams. Of course, I meant Slack. We use Teams at work, so that's why I say Teams all the time. That's the that's that. Then there is the there's the steps here. Okay, I'm gonna put that in. So All right, so the code, the steps are there. So please go ahead. How much time do you guys need? 15, 20 minutes, will that do? Or less?
15 is good, I think.
Okay.
Mhm.
All right, well, I'll be here. So for what is it, for almost 4:40 for 55 or something, a little earlier than that. So see if you can get this to working code. So again, I pasted that in code well. So test it, and please, as we discussed as a bonus challenge, we didn't put that here, but think how you're going to incorporate those. Don't go all the way to the end, right? So as you go in here, you don't want to go through each element. Right here we have for each element in the array until changes are made. So may want to start doing somewhere, not for each element. Every iteration, remember the last element becomes at this fine at the last point. So see if you can make it a little bit more elegant. So, all right. Let me know if any questions. I'll be here. Thank you.
a little bit hard to figure out this I think.
Mhm.
Yeah, although I suggested it when I was trying to implement it, it was giving me a out of bounds exception. And I remember that it's supposed to be -1 too.
Mm. Yeah, okay. All right, well, so then that looks good. Yeah, I mean, your variables look good. Everything is it's like it works. So nice job. Cool.
Thanks. I just implemented your pseudocode.
All right. Any issues from anybody else on making it work? All right. Well, then if that's good, then I guess you guys are now familiar with the bubble sort. So that's really remember that if it comes up on the interview question, bubble sort is really think about bubbling up, right? Each element to the top. So with each iteration, you take the first element, and starting from the first element, you kind of compare to the next one and get the largest element for each iteration all the way to the right. And then you do the same thing the next iteration, next iteration, next iteration. So with each iteration, you should have the last element prior, and so on in the right position. So just bubbling up. Okay, so and then for next time on next Thursday, so we will go through a couple other sort things. So we're gonna go through insertion sort. So you're gonna get some practice in that. So also very simple technique for sorting, and you're going to be practicing that. It's also for small data sets, and also there is a merge sort that we probably gonna get to on the next class. And let's also leave the rest of the quick sort for the next class as well. I need to cut this a little bit shorter today, but we will also look at the the quick sort. So if you guys have more time, take a look. But if not, that's okay. We will go through that again together and do some actual coding just to finish that. So. All right, well, let me know if there are any questions. If not, I'll let you go early today just to get a little break before your main class.
Thank you. Good.
All
Thank you.
right.
Thank
All
you.
right. See you guys next week. Have a good weekend.
Thank you.